Hello and welcome. In the last two videos, we saw how we can make linear regression models, and also we discussed in general how regression models are built through these examples of linear regression models. Now, once we have a number of regression models, we need to be having a method to determine how good which regression model is, and so that we can pick the best model for our utilization. In this video, I will discuss how we can find the best regression model and what are the parameters which can help us in doing so. We will use Excel for our understanding purpose. Later, we will apply the same techniques on Python programming. So here we are in Excel. We had computed the linear regression equation for this particular set of data, where we are predicting for scaled sound pressure level based on these 5 variables, that is frequency, attack angle, chord length, free stream velocity and thickness. Now, so this was our variable y. So let me write it as y. So this is our variable y. Now let us try to find the predicted y based on the equation what we have found. So predicted y, let me call it as yp. So let us calculate this now. We know how to do that. So I will just color this. So here we are. So I can say this is equal to the intercept plus beta 1 into frequency plus beta 2 into attack angle plus beta 3 into chord length plus beta 4 into free stream velocity plus thickness into the beta 5 into thickness. Now our betas are all constant, so I will anchor these cells. And there we have our formula. So now you can see I could calculate the predicted y. So I can just copy this across the entire data. So we have the predicted value for all the different sets of input data that we have got. Now let me introduce some more columns here because we will use it for calculation. So I insert these columns. Now let us calculate the residual. We know that the residual is nothing but the actual value minus the predicted value. So let us calculate the residual. So that is simple. I could just say this is the actual value y minus the predicted value. The residual can be positive or negative based on whether the prediction has been more or less than what it actually is. So now I can copy this residual across all the data items that we have got. So there the residuals are calculated. Now let me find out the residual squared. So this is residual to the power 2. So this is also simple. I could just say this to the power 2. Now let me copy this. Once we have the individual residual squares, what I can do is that I can find the sum of square error. This is SSE. So I could calculate this. So I could say right align this. So this is nothing but sum of all the residual squares that we have determined. So I have computed that. So if you notice in the computations what it has done, it has found out that the sum of square errors is nothing but here. The residual square sum is here. This is the same value as what we have also computed. Now from this I could figure out the mean square error or MSC, mean square error. So mean square error, this is nothing but the average of all the residual squares that we have determined. So this is my mean square error. Now mean square error This is one of the parameters based on which we can determine the goodness of our model. The lesser the mean square error, the better our model is. So this is one of the measures for us to look out for in terms of determining whether our linear regression model has been good or not. From mean square error, we could have determined one more value, which is known as the root mean square error, RMSE. So from we could have found this from the mean square error. This is nothing but the square root of the mean square error. So this is our root mean square error. So mean square error and root mean square error are a value based on which we can determine the goodness of our model, and these values have to be as less as possible for the model to be considered as better than any other model. Okay, now we have got this. Let us determine some more figures now. Now we have got all the values of y. So from this we can find the mean value of y. So mean of y, I will call this as ym. So let us calculate that. This is simple. I can just say average of all the values of y. So there I get the mean of y. Based on the mean of y, I can find out a figure which is known as the y minus y mean, and I will square this. So I will square this. It will become very clear why I am doing this very quick soon. So let us first determine this figure. So I can say y minus the mean of y, and this whole stuff I will square it. So there we have got this. So I can just copy this across. So now we have determined this. Now this figure, what we have determined, this mean of I has to be anchored, then this calculation will be correct. So now when I do this, we will have all the correct figures. Now if we sum up all these figures that we have determined, y minus y mean, that is known as the total square error, or TSE. So let us determine this TSE. This is nothing but the sum of all the square errors. So we have found this figure. Now from this figure of SSC and TSC, we can find a very important measure which is known as R squared. R squared. R squared is nothing but equal to 1 minus SSC divided by TSC. So we can find this. So I say equal to 1 minus SSC divided by TSC. So I get a figure of 0.5157. Notice that our data analytic toolkit also determined R square is equal to this. Now what does R square mean? R square can take a value between 0 and 1. If the value is closer to 1, that means our model is able to make predictions or able to correlate the independent variables more closely with the dependent variable. And if the model is close to 0, that means our model is not doing so well. So this is one figure which needs to have a high value, that is a value as close to 1 as possible, for our model to be considered as a good model. So when we have multiple models, the model which has a higher R squared value can be safely considered to be the better model among those models. So this is one measure which we need to determine. Now notice one thing. When we did the regression based on a single variable, we got a R square of 0.15. And when we took 5 variables together, we got a R square of 0.5157. So when we are taking all the 5 variables together, our model is better than when we are just considering frequency to determine the value of scaled sound pressure level. So you could see that we already know that this model is better than the model where we had taken a single variable frequency for making our prediction. Now let us look at some more measures which can help us to determine the goodness of our model. Now, let us determine one figure, which is the absolute value of the error. That is absolute value of y minus y prediction. If I do this, what I get is that I can say absolute value of y minus y predicted. So I have got this. I could copy this across. So there I have determined the value of y minus y predicted absolute value. So the absolute value will always be positive. Now what I could do is that I could find out the absolute value of y minus y predicted and divided by y. So if I do this, this is equal to absolute value of y minus y predicted divided by y. So if I do this now, this is equal to this divided by y. So this is a figure which I could represent as a percentage. So if I see that, it is giving me a value in percentage. So this is the absolute percentage error in my prediction. If I take a mean of this, this becomes the mean absolute percentage error, or MAPE. So I could determine that now. This is nothing but I take the average of all these values that I have computed. Average of all these absolute percentage errors. If I take that, so this gives me the mean absolute percentage error. Now this mean absolute percentage error is another measure of the goodness of my model. So the lesser the mean absolute percentage error is, the better my model is going to be. So I will just expand this so that you can see that. So this is another measure by which we can determine the goodness of our model. So we have seen that we have got some measures based on which we can find out whether a model is good or bad, and we could compute this after computing our model to determine or to compare our model with other models that we will be using for regression.